in the Verilog code, we have 5 modules. I will start off by explaining what these modules are. We have the 7-segment decoder, that the module of the 7-segment decoder that takes a number, and then we looked up the 7-bit representations on the 7-segment decoder of each number, and we made a case on the number, and according to which number we have, it will output a 7-bit binary number that will be fed into the 7-segment decoder to actually display the number. The 7-segment display on the FPGA is an active low, so that is something that is different from the rest of 7-segment decoders. The other module that we used is the clock generator, as the clock on the Altera board is 25 megahertz. 25 megahertz or no, 50? 25 megahertz. So we generated a slower clock that would take on the positive edge of the fast clock, and we have another counter. And on each positive edge of the fast clock, we increment a counter until this counter reaches 25 million times. After it reaches 25 million times, it increments our actual slow clock that we will be using throughout this entire code by 1. Thus, we have each clock cycle of the slow clock that is generated is 1 second in real life. Another module that we have used is the car space module that takes as input the sensor of a car of 1 parking space. It takes as input the green light of 1 parking space, and the input is the yellow light of also 1 parking space. It outputs the green light that will be represented, and the red light that will be represented, and the yellow light that will be represented. Initially, the green light is initialized as 1, the yellow light is initialized as 0, and the red light is initialized as 0. Our sensors were active low, so when the sensor was equals to 0, the green light would be equals to 0, and the red light would be equals to 1. If we have the yellow light of the car space, if the input is 1, we turn off all other lights and we only illuminate the yellow light. If the case is that the sensor is not reading a 0, which means that there is no obstacle in front of the sensor. Then we have a rather large module that is called entrance exit, that handles everything that happens on the gates, such as reservation and counting cars. My partner here will talk to you more about this module. However, I will jump this module and talk about our main module, which is called module Smart Parking. This module takes in the clock of the FPGA. It takes in the 4 sensors of each parking spot. It takes in also the 2 sensors of each gate. It takes in the password switches that we have used, and it takes in the switch that we have used to represent the reservation. It also takes, these are the inputs, and the outputs are the green lights of each, and the green, yellow, and red lights of each parking space, as well as the green, as well as it outputs the green light that represents that the correct password has been entered. Another thing that we output is the 7-bit digits of the 7-segment display. Moving into this module, we make 1 instance of the entrance exit module that handles everything, as I previously mentioned, that happens on the gates. And we make 4 instances of the car space module that handles each car space. Each module of the car space represents 1 parking space. It takes in its own the sensor of said parking space, the green light of this parking space, as well as its yellow light, and it outputs the green light of its parking space, the red light, and the yellow light. And this is basically our main module that is that we run when actually executing this very long code. Now my partner Nadine will talk to you further about the entrance and exit module.
The entrance and exit module handles the entrance and exit gates. It takes in the clock of the Altera. It takes in the sensors of the 4 spaces. Takes in the sensors of the entrance and the exit gate, as well as the password entered by the person who reserved a spot, and the 2 switches that indicate the person has reserved the space or is entering a password for the reserved space. The output for that is the green light, which indicates that the password entered has been correct, the digits on the LCD, the 7 segments, and it outputs the first output of the green and the yellow lights of each parking space. On the inside, we have had the parameters and the temperature registers that we use. At first, we initialize everything with 0, and then going in, for example, when the person when the person indicates on the switch that he's entering a password to reserve a space, this password is saved inside, and we start a certain counter that stays on for 15 seconds, which is the reservation period. And then when the person enters the password, when they click on the switch, they're entering the correct password. We enter and see if they enter the correct password. If so, we eliminate the green light, and then we start. And if not, the green light is not eliminated, indicating that the password is wrong. We then make all those blocks for the sensors, the input sensor and the output sensor, such that for the gates, such that when a car is near when the sensor senses a car, it goes to the state. We have 2 states called car and then no car. The car indicates that we're going to enter a car into the parking space, and then we have an always block for the clock. These are things that are checked whenever the clock is entered, whenever the clock is at the positive edge. And then we have for each state also an always block that checks the incremental for the counter, and at the end the count is entered for the 7-segment decoder module to produce the digits on the LCD.
Connected to our breadboard and FPGA board, we have 6 FC51 proximity sensors. 2 of them represent enter and exit gates, and 4 of them are for the parking spots. The 2 sensors for the enter and exit gates have a potentiometer that can be adjusted to a maximum distance of 10 centimeters. And the 4 sensors for the parking spots have potentiometers that can be adjusted to a maximum distance of 3 centimeters. Each sensor in a parking spot have 3 LEDs, 1 green, 1 red, and 1 yellow. The green one lights up when the parking spot is free. The red one when the parking spot is not free, and the yellow one is when the parking spot is reserved.
Okay, the LED lights are connected to the common ground, which is connected to the Arduino board on the FPGA, and they are also connected in series with the GPO pins, the GPO output pins on the Altera board that gives them 3.3 volts of power.
So, as my colleague said, we have 5 FC51 proximity sensors. They're connected all to our FPGA. So the proximity sensors have 3 pins, a VCC, a ground, and an output pin. So we have a common VCC connected to the FPGA Arduino pin that supplies 5 volts of power. We have a common ground that's connected to the ground Arduino pin on the FPGA, and we have the output of the proximity sensors is also connected to the input pin on the Arduino FPGA. So, action.
In this segment, we'll talk about the scenarios and how each car enters the parking system. As you can see, there are 4 LED green lights that are illuminated right now to indicate that there are 4 available parking spots. As we enter the first car through the enter gate, the count on the board indicates that the number of available spots drops from 43. Then this car enters right here and parks. The LED changes from green to red to indicate that this parking spot is taken. Next, now we'll talk about the reservation system. First off, to reserve, we put the password. We'll first reserve, then put the password. As you can see, the yellow LED is illuminated right now to indicate that this parking spot is reserved. But for right now, we'll attempt to reserve a parking spot by flicking this switch to indicate that a password has been entered. As you can see, the yellow LED has illuminated to indicate that this parking spot is now reserved. But now we will not enter a car in this spot, and after 15 seconds, it should go back to the green LED. In this scenario, we now attempt to write enter a password, then enter a wrong password. As you can see, this green light bulb did not illuminate, which means that the password that was entered is the incorrect one.
Okay, now I'm going to demonstrate how to correctly enter a password. First, I register like this, okay? Then I enter the correct password like so, and turn on the password like this. As you can see, this green light has turned on, and seeing as the first parking spot has been taken, the second parking spot has been reserved by the yellow light.
So for this scenario, we're going to demonstrate how when we reserve and actually enter the car, things will go. So as my colleagues demonstrated, we're going to reserve by flipping the second switch right here, on, and so here's the yellow spot. The car is now reserved, and we're going to enter the password directly. Then the car will enter. It'll be parked right here. So that's it. The counter is now done. Now for the final scenario, we're going to demonstrate when the car actually leaves exit the parking. So we're going to exit right here, and again. So here the counter incremented by 1.